astronomers say that 3I Atlas is turning green, they are not talking about paint, lights, or anything remotely artificial. They are describing a very specific and very real change in how the object interacts with sunlight. And while the phrase sounds dramatic, the science behind it is grounded, familiar, and quietly revealing. Something is activating, but it is not what the internet wants it to be. It is chemistry, physics, and temperature finally crossing a threshold. Green in space has a long history. Some of the most famous comets in history have taken on a greenish glow as they approach the sun. That color does not come from ice or rock directly. It comes from molecules released into space and then broken apart by solar radiation. When those fragments relax back into lower energy states, they emit light at very specific wavelengths. One of the most common of these emissions happens to fall in the green part of the spectrum. The usual culprit is a molecule called diatomic carbon, often written as C2. When carbon-based compounds are released from a comet's surface, sunlight breaks them apart. Some of the fragments briefly form C2, which fluoresces green when excited by ultraviolet light. This glow is faint, ghostly, and often invisible to the naked eye, but sensitive telescopes pick it up clearly. If 3I Atlas is showing a green tint, it strongly suggests that carbon-bearing material is being released and processed by sunlight. What makes this noteworthy is that 3I Atlas did not initially look active. Early observations showed a dim, almost point-like object with no obvious coma or tail. That suggested a relatively inert body, possibly depleted of volatiles after spending eons in interstellar space. A shift toward green implies that assumption may need updating. It suggests that at least some volatile material has survived the journey and is now responding to solar heating. Activation does not mean a dramatic eruption. It does not mean jets blasting into space. In many cases, it means the slow, almost reluctant release of gas from beneath a weathered surface. Interstellar objects are expected to have crusts hardened by radiation, cosmic rays, and micrometeorite impacts. As 3I Atlas warms, that crust can crack or thin, allowing trapped compounds to escape. The process can be uneven, localized, and subtle, but its spectral signature is unmistakable. The green color is not uniform. It often appears concentrated around the object, forming a faint coma. This coma is not a solid cloud, but a diffuse envelope of gas expanding outward. The reason green stands out is that C2 emissions are relatively strong compared to the surrounding continuum of reflected sunlight. Even a small amount can shift the overall color detected by instruments. Another molecule sometimes involved is cyanogen, CN, which can also contribute to greenish emissions. Despite its intimidating name, cyanogen is a common cometary molecule and does not imply anything exotic or dangerous. Its presence would further confirm that 3I Atlas is releasing complex carbon compounds, something that has implications for how planetary systems distribute organic material across the galaxy. The timing of this change matters. Color shifts often occur when an object crosses a thermal boundary, where surface temperatures become high enough to sublimate specific compounds. For water ice, that threshold is relatively close to the sun. For more volatile substances like carbon monoxide or carbon dioxide, it can happen much farther out. If 3I Atlas is turning green at a larger distance than typical comets, it suggests a composition rich in highly volatile ices. That possibility excites astronomers because it hints at formation conditions around another star. Different protoplanetary disks produce different chemical inventories depending on temperature, pressure, and stellar radiation. Seeing which molecules activate first tells a story about where and how the object formed. In that sense, the green glow is not just a visual change. It is a chemical fingerprint from another solar system. It is also important to understand what green does not mean. It does not mean the object is heating up dramatically. It does not mean it is becoming dangerous or unstable. It does not mean it is emitting radiation in any harmful sense. The emissions involved are extremely faint and purely diagnostic. They tell astronomers what is happening, not that something is going wrong. There is also no reason to invoke artificial explanations. Green emission is one of the most well-documented and well-understood phenomena in cometary science. If anything, its appearance argues for a natural origin. Technology tends to produce broad-spectrum emissions or narrow, engineered lines. not the messy molecular fluorescence seen here. Nature, by contrast, is perfectly comfortable glowing softly in one color because that is what the physics allows. What is different in this case is the context. 3I Atlas is not a native of our solar system. Its green activation is happening under conditions that differ from those of typical comets we observe every year. That gives scientists a rare opportunity to test their models against something truly foreign. Do interstellar objects behave like our comets when they warm? Or do they reveal new pathways of activation? Early green emission could also explain why the object's brightness may change in unexpected ways. As gas is released, it can carry dust with it, increasing the object's effective cross-section and reflectivity. Even a slight increase can make the object appear brighter than predicted. This can create the illusion of sudden activity when, in reality, it is a gradual transition that finally becomes detectable. Observationally, confirming a green tint requires more than a pretty image. Astronomers rely on narrowband filters and spectroscopy to isolate the specific emission lines involved. By measuring their intensity over time, they can track how the activity evolves. Does it strengthen as 3I Atlas approaches the Sun? Does it fade unexpectedly? Does it shift toward other colors as different molecules become active? Each answer adds depth to the picture. There is also a dynamic component. The solar wind interacts with the released gas, shaping the coma and any developing tail. This interaction can stretch the green emission into asymmetric shapes, revealing the direction of gas flow and the object's orientation. These details help constrain rotation, surface heterogeneity, and thermal properties. From a broader perspective, the green glow carries philosophical weight. It means that material from another star system is reacting to our Sun in a familiar way. The same photons that activate comets born near Jupiter or Neptune are now activating something formed light years away. Physics does not care where you come from. The rules apply universally. That universality is the real story. Not aliens, not mystery technology, just the quiet consistency of chemistry across the galaxy. Carbon bonds break. Molecules fluoresce. Light gets emitted at predictable wavelengths. And we, watching from one small planet, recognize the pattern. As 3I Atlas continues its journey, the green may intensify, fade, or give way to other emissions. Each change will be tracked, debated, and modeled. None of it means the object is awakening in any dramatic sense. It means it is responding to warmth, responding to radiation, responding to the same forces that shape every icy body that ventures inward. So yes, 3I Atlas is turning green. Something is activating. But what is activating is not intent or intelligence. It is chemistry finally given enough energy to speak.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.